So in this section, I'm going through S1 and it's section 2.3 and it's titled Other Measures of Location. Now, measures of location, they focus on a specific value in the dataset. The median describes the middle of the dataset, but there are also other measures of locations, such as quartiles, which you've come across before at GCSE, and percentiles. The lower quartile is 1/4 of the way through the dataset, it's 25%. The upper quartile is 3/4, it's 75% of the way through the datasets. Percentiles, which are different, they split the dataset into 100 parts. So the 10th percentile is 1/10 of the way through the data. 10% is the 10th percentile. Use these rules to find the upper and lower quartile for discrete data from a list, for example. To find the lower quartile for discrete data, divide n, the number of numbers in your data, by 4. It's 25%. If this is a whole number, and that's important, if this is a whole number, the lower quartile is halfway between this data point and the one above. So if you get the answer as 4, a whole number, you know that your quartile is between 4 and 5. It's basically 4.5. If it is not a whole number, you round up. You always round up, regardless of the decimal that you get, and pick that data point. And it's the same for the upper quartile. If you get a whole number, once you've done 75% of n, the upper quartile is halfway between this data point and the one above. If it is not a whole number, round up. Again, always round up. Okay, so let's have a look at this. The data shows below how far in kilometers 20 employees live from their place of work. Find the median and the quartiles for this data. Now, this is discrete data. So the median is called quartile 2 because it's in the middle. And the lower quartile is quartile 1 and the upper quartile is quartile 3. So the median, there's 20 numbers because there's 20 employees. So it's 20 plus 1, I don't change anything, divided by 2, so that's 21 divided by 2, so that's the 10.5th value. So you know that you want between the 10th value and the 11th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the 11th value. So 10 and 11 are there. So it's 7 plus 9 divided by 2, and that is going to give us the median of 8. The lower quartile, so that's the median, the lower quartile is 20 divided by 4. I didn't add 1 like I do with the median. So 20 divided by 4 gives me 5. That's a whole number. So it's going to be between the 5th and the 6th values. If it's a whole number, I know it's going to be between the 5th and the 6th. So let's count 1, 2, 3, 4, 5, and 6. Well, they're actually both the same number. So the lower quartile is 4. You could have done 4 plus 4 divided by 2, you'll still get 4. So if it's the same number, that's great. And then the upper quartile, which is 75% of the way, upper quartile, quartile 3, is 0.75 times 20, which is the 15th value. And again, it's between, because it's a whole number, it's between the 15th and the 16th. So I know up to here is 10, 11, 12, 13, 14, 15, 16. So again, I add them up and divide by 2, and that's 12.5. So the upper quartile is 12.5. Now, when the data is presented in a grouped frequency table, we are estimating, and we don't really know where the quartile is going, like the value of the quartile is going to be exactly. So for grouped continuous data or data presented in a cumulative frequency table, the lower quartile we find by doing n divided by 4. The second quartile, basically the median, we do by doing n divided by 2, so not n plus 1 divided by 2. And the upper quartile is 75% of the data. Now, we're going to use a method called interpolation, and it's important to understand that when you use interpolation, you are assuming that the data values are evenly distributed within each class. Okay, so that they're not all 30. For example, these 25, frequency of 25 people, how many minutes did they spend on the internet each evening? Well, I'm not going to assume that all of the 25 are 32, or all of the 25 are 33, or all of the 25 are 32.5. I'm going to assume that this 25 people are evenly spread across the 32 to 33 range. So for this example, it says the length of time to the nearest minute spent on the internet each evening by a group of students is shown in the table. Find an estimate for the upper quartile, find an estimate for the 10th percentile. So let's start with the upper quartile. So the upper quartile is 0.75 times n, and n is the total frequency. So we have to do 2 plus 25 plus 30 plus 13, and it is 70. So that's 75 times 70, which is 0.75 times 70 is 52.5th value. Now, this is not discrete data, so don't round up, don't do anything like that. This was only for discrete data, okay? So data that's in a list or a frequency table, but not a grouped frequency table. So let's have a look. Which class is the 52.5th value? So let's start adding these up, do a kind of cumulative frequency. It's certainly not 30 to 31 because there's only 2 people there. If I add 25, that gives me 27 people. So it's not going to be here either. If I add 30, I get 57 values. Therefore, the upper quartile is in the 34 to 36 class. I know that, and I know that the values are continuous. So even though the number of minutes, it says this ends at 33 and this starts at 34, but what happens to people who do 33.2 minutes or 33.3 minutes? So it's continuous. There's a range. So there's something missing here, the people that are above 33, below 34. So I'm going to assume that the class range is a bit bigger. So 34, I'm going to take away 0.5, and I'm going to say that this class actually starts at 33.5. And then with the upper limit of the class, 36, I'm going to add 0.5. I'm going to say that the class limits end. So I'm kind of extending the class limits or the class boundaries each way, both ways, up and down. And then I'm going to use interpolation, and I'm going to show you what they do in the textbook and why they do that. But they basically create a number line. So they create a number line. and for the class. So this is a number line for the class, for the group. Number line for the group or class. So we know it starts at 33.5. We've said that. And we know it ends at 36.5. And we know that the upper quartile is somewhere on the line. In fact, I won't put it there. We also know that we start here. I know technically we start on the 28th value, but this is continuous. So we're going to start at the lower limit or the upper limit of the class before. So 27th value is here because remember there is an overlap. 33.5, it's not quite 34. So that's why we start with the upper limit. 2 plus 25 is 27, so 27th value. And we know that we end here on the 57th value. And we've already worked out that our upper quartile is around here. We don't know what the value of it is, but we do know it's 52.5. And what we're going to do is we're going to use proportion, the proportion of, so we're going to use the proportion, let me get some space, of that number line to work out our upper quartile. We're basically saying this distance out of the whole distance is equal to this distance out of that bigger distance, because they're the same thing. So we're using proportion to work out so Q3 minus 33.5, that smaller distance, divided by the bigger distance, 36.5 minus 33.5. So the smaller distance as a proportion, as a ratio of the bigger distance, is that same smaller distance, 52.5 minus 27, divided by the bigger distance, which is 57 minus 27. And you can straight away multiply to get rid of the fraction. So this is what I would type. I would type in the fraction 52.5 minus 27 over 57 minus 27, and then times, I'd put that in bracket, 36.5 minus 33.5. And I would get that the upper quartile minus 33.5 equals 2.55. Therefore, I'm going to add 33.5, so add 33.5, and it gives you 36.05, and that is the value, an estimate really, for the value of the upper quartile. So that's the upper quartile using interpolation. And question B says find the 10th percentile. So that is 10 out of 100, or 0.1 times 70. And that gives us the 7th value. We're looking for the 7th value. And again, I'm going up and I'm looking at my table and I'm thinking, well, where is the 7th value? It's not in the first class. It has to be in the second class because 2 plus 25 is 27. So I've very much passed that. So 2 plus 25 is 27. So we are looking at the 10th percentile is in the 32 to 33 class. Again, I'm going to create some space so we can do this. And again, I'm going to, assume that the class is a bit bigger than it is. So it is, instead of starting at 32, it's going to start at 31.5. And instead of ending at 33, it's going to end at 33.5. And I'm going to create my number line for my class. And my class starts at 31.5. My class ends at 33.5. By the same token, the class, even though technically this is the third value to the 25th value, I'm going to take the limit from the class below, because there's overlap between 31.5 and so I'm going to say that this is the second value, and 2 plus 25 is 27, so this is the last value, and the 10th percentile, P10, is somewhere there, and we've already decided that it's the 7th value. So this is 27th value, second value. And I'm going to use my proportion. So P10, which is the 10th percentile, minus 31.5. So again, that smaller distance divided by the bigger distance, and then that small distance divided by that bigger distance. 7 minus 2 equals, sorry, not 7 minus 2, 33.5 minus 31.5. And then we've got the smaller distance, so 7 minus 2 over 27 minus 2. And again, I'm going to put it in my calculator, I'm going to multiply, and then I'm going to add 31.5. So that gives me the 10th percentile is 31.9. And that is the end of this section, section 2.3.